Hi, this is Dr. Ramu, Professor, Head of Computer Science Engineering, Narsimha Engineering College, Hyderabad. In last class, we have seen that the data abstraction. Right? In today's class, we are going to see the data independence and the structure of DBMS. And data independence also discussed in the last class. Right? The data independence is going to give the flexibility between the various models, right? From the view level and conceptual level and the physical level, this is going to give the clear independence. It means if you change some data in the one level, it is not going to affect the other models, other levels, right? The same thing, we're going to see some extension, the same in the data independence. The data independence. Here, the data independence, if you observe that, the definition data independence refers to the capability to change the schema to at one level without affecting, without altering, right? Without altering the schema at the other level. That is called as a data independence. Coming to the importance, it is going to reduce the complexity and simplifies the application development, right? So if you can take the application, for example, if you implement the application, the Java and the C++, right, and the Python, right, it is going to give the clear view of the application programmer perspective, right? And the types of data independence. These are two types of data independence: logical and the physical. Logical and the physical. Coming to the logical, the ability to change the logical schema without all affecting the external, means the view level. Without changing the view level, right, we are going to change the model. That is called as a right logical independence. Coming to the physical independence, ability to change the physical schema, right, physical schema without affecting the logical schema. We know that the three levels are there: view level, logical level and the physical level, right? If you change something here, right, it is not going to affect the logical view level. If you do some changes in the physical level, it is not going to affect in the logical level. These things are going to concentrate on the data independence. The challenges in achieving the data independence, right? The first one is the dependency of the database design, right? The database design, you should plan accordingly the physical level, right? And the what it is called the view level, right? If you do some changes in the database design, it is not at all going to, right, affect the user level. And the balancing the performance, right, while designing and while maintaining the data independence, we should ensure that, right, we should balance the performance. For example, you did a real great design, but it is not going to, right, give the results in the on time, right? Entire design it is going to waste. Yes or no? Right? While designing, you should keep in the mind the performance, right? The performance is a very what important metric while designing the database. And the next, ensure the compatibility during the schema changes, right? Once you change any design changes in the schema, right, definitely you should have an idea, right, how it is going to affect in the external level. Based on that, you should design the your logical schema. And right now we'll see the structure of DBMS, database management system. Typically the structure of based on the relational model, right? Entire the subject we are going to consider in the relational data model. This is a top model. Same, it is a view model, right, and logical model, and same, right, physical model. Application interface for the user and the end users, right? End users, right? How we are going to extract the data based on their needs. And the middle part is a query processing and the storage manager, right? How it is going to give the data to the user, right? It is based on the middle part. And coming to the lowest part is a disk storage, right? How we are going to store the data in the indexes format, right? And we'll see the structure of the DBMS architecture, right? This is various users are there. If you observe that, users, application programmers, right, the developers and the sophisticated users and the database administrator, right, these persons are going to interact with the query processor based on the various interfaces, right? So it's the application interfaces application programs like a Java, right, other programs, and the query tools, right, the SQL, and that so administrative tools, right. And in the query process, we are going to see the various components, right, compilers, linkers, right, DML, data manipulation language queries, and data definition language interpreters, right, and DML compilers and the organizers, right, application programmer and the object code, right. And coming to the query evaluation engine, right, we'll see all these components one by one in the upcoming slides. The key components of the query processor, right, data definition language, DDL, data definition language, data manipulation language, and query evaluation means here we are going to create the database, and here we are going to manage means we need to update, we need to change, right, the data, and the query evaluation engine, right. And so data interpreter here translate the DDL statements into the data dictionaries, right. We design the some, for example, if you want to create a table, right, this is going to convert into the dictionaries, and dictionaries it is going to store the metadata. And DML, data manipulation, translate the DML statements into the evaluation plans, right, and generate the instructions for the query evaluation engine. Got it? And next, query evaluation engine, right. So here it executes the low level instructions, right, based on the user inputs, and optimize the evaluation queries and using the execution plan. See, once you give the query, right, it is going to give the results at the in time, right, on time. Otherwise, the system or design, the entire system, it is going to null and void, right. There is no use the system which is going to give the timely result. Query optimization and the storage management, right. The optimizer produces the efficient execution plan based on the storage data, and the plans to serve the blueprints for the query execution, right. The query which you are going to give to the the database system, it is going to execute accordingly, right. The storage manager, right, it interface between the database storage and the application queries. The responsibilities of the storage manager is storing and retrieving and updating the data. This is the storage manager responsibility. So we'll see the storage manager components. It has the authorization and integrity manager, and the transaction manager, and the file manager, and the buffer manager. Coming to the authorization integrity manager, right? So validate the user access. Validate the user access, right? Whether the particular user is is able to access the respected things or not, right? Is there any restriction is there, right? Ensure the integrity constraints, right? Integrity constraints, like whether the consistency and the right, the redundancy, right? So is there any there in the constraints as, and a transaction manager, right? They maintain the consistency during the system failures. For example, in ATM, you insert in a code, right? And you, right, enter the amount what you want to withdraw. For example, I entered 10,000 rupees, right? After entering the 10,000 rupees, what happened? The amount was detected, and I got a message. But suddenly the system was restarted. Then what happened? My amount is not what it is called dispatched by the mission, but amount was detected in my mission. What it is called my mobile, right? My account. Then in the particular situations, what it is going? The transaction is going to roll back. Means again, when the system crashes happen, right, the transactions are going to get back to the original. For example, if the 10,000 is detected, for example, in your system, your account, 1 lakh amount is there, right? And the 10,000 is detected, then the amount is 90,000, right? If it is not dispatched, then this is going to roll back. Roll back means again the amount will get the original amount, the 1 lakh will get it back. This is going to assured by the right consistency during the system failures. And the manage the concurrent transactions. For example, X person is depositing an account in our right amount, and Y person is withdrawing the amount, right? These two things are going to concurrent. It is going to support. And the file manager allocate the files in the disk storage and represent the stored information as well, right? Next, the buffer manager. In the buffer manages the data fetching from the disk memory and decides the caching strategies for the efficiency also. Got it? These are the components of the storage manager which is going to work. And the storage manager is going to find the data files and the data dictionaries and the indices. The data files that contains the actual database data, right? And the dictionaries is the metadata to store the metadata and the schema information. And the indices enables a fast access to the data item. For example, for everything there is an index is there. So based on that index it is going to access, then you will get the data, the fast accessing also. And the next, importance of the storage manager. The why, what is the role of the storage manager? Ensures the efficiency and the data management, right? Efficient data management, and the critical for the query execution and the performance, and the manages the database consistency and the reliability. These are the 4 points that the storage manager is going to concentrate in the architecture of the database management systems. Okay, and in the next class we are going to see the database design and the ER diagrams. Okay, thank you.